math induction? Of course, this math induction or mathematical induction you are seeing is a way of proof in mathematics. It's a way of what? Proof. There are many ways to prove in mathematics. Number one, you can prove by direct proof. You can prove directly. You can prove by induction. When they say prove by induction, it means by math induction. You can prove by contrapositive, by contradiction, and you can prove by considering cases as well. But then, my point is that math induction is a method or part of the techniques in proving some mathematical theorems. Do you understand? Now, what is it talking about? It's very simple. The underlying principle, like when you are talking about math induction, you are talking about the set of real numbers and natural numbers. What is natural number? 1, 2, 3, 4, 5, and it goes on like that. Do you understand? Now, for your level, when you are told to prove by induction, you are proving based on this set. Do you understand? When n is 1, when n is 2, when n is 3. You can't be proving by induction and be saying when n is 2.3. Do you understand? When n is root 2. It doesn't work that way. Although in higher level mathematics, it is extended to all those kind of things, set of rational numbers. But now for math, you just need this. Do you understand? Now, the first thing on induction as well, when you want to prove, I'm giving you a summary. The first thing you need to take note is that you have to prove for n equal 1. I will put 2 there because you are just learning it. But in reality, when you are proving by induction, you can prove. This is called the base step. Do you understand? The base step means that you will first prove, when you want to prove by induction, prove that it is true for n equal 1. Do you understand? Although during this lecture, I will take time to also prove that it is true for n equal 2. Do you understand? That is the first thing you will do. The second one, you will prove that what? Assume it is true for some n equal k. This one also means something, don't worry. By the time I'm done writing all what you need to do, all what you are going to do to conclude what we call induction, I will explain all these things. Although I'm looking at some people's face, it's already looking ambiguous. Don't worry, it's so simple. Now, then, the last thing to do is prove for n equal k plus 1. Do you understand? Once you are able to do these 3 things, you're done. Do you understand? Now, for example, look at this, n factorial and n squared, right? Which one is greater? How do you know? How do you know that n factorial is bigger than n squared? What if I say it's less? Am I correct? You check. That is induction. They can say something. I deliberately put this example to show you something. If I am told to prove by induction, or if you are told to prove this, you can actually prove by induction, because all this n, so they say for all n, or when n is inside the set of natural numbers, or they can say when n is greater than or equal to 5, something like that. When they say for all n in the set of natural numbers, it means that when n is 1, when n is 2, when n is 3, and on like that. When they say for all n greater than or equal 5, it means from 5 and above. Do you understand? Now, check 1. Do you understand? When you check 1 factorial is what? 1, right? 1 square is still 1. You see? This is wrong. Or let me do this way. We say equality odd, right? Check 2. 2 square, 2 factorial, 2. 2 square is what? 4. 2 is less than 4, right? You see what I'm saying? This is like you are proving for n equal 1 and 2. You put n to be 1. Check whether it's correct, whether what you are giving is actually true. Do you understand? Like in this case, n factorial, you put 1. 1 is equal to 1. That's true, right? You put 2. 2 factorial is 2. 2 square is 4. 2 is less than 4. That's also true. Do you understand? How are we sure? Now, this is for this first case. If you put 3 now, let's say for example, let's put 3. 3 factorial is 6, right?
Yes.
3 square is what? Is that how we continue going? Where will you stop? Do you understand? So that's like the basic step. Check for n equal 1 or 2. Now this second one means that assume it is true for some n equal k, that is okay. I have checked for 1, it's true, right? I've checked for 2, it's true. Do you understand me? I've checked for 3, it's true. Now, how am I sure that if I check for 4, 5, 6, 7, 8, 9, 10, it will always be true? You can't continue going that way. Do you understand? So you have to assume, okay, let us assume that oh, it's only true for the first 10. Do you understand? Like, you know, I've checked for when n is 1, when n is 2, when n is 3. Do you understand my point? You can't keep checking for when n is 4, when n is 5, when n is 6. Where will you stop? It means it says for all n or n greater than 5, it's an infinite number. Do you understand? You can't stop at 100 even if you have the power to do from 1 to 100. Do you understand? So that's the meaning of this bit. Assume it is true for some n equal k, that oh, let us assume that it is true for the first 10. Do you understand? Now you now prove. Let us check whether it will not be true for 11. K plus 1. Do you understand? Or let us assume it is true for the first 100. How about 101? Will it be true? That's the meaning of k plus 1. Do you understand? So, and if it's true, that means anywhere you stop, anywhere you assume, well, let us assume it is true for the first 1000. Will it be true for the next number after 1000? If that's true, then it will be true for all. How do I know? Because this n equal k means that you can stop anywhere. So once you stop there, from here to here, it stops here. Then if I move further, that means the meaning of this thing is that from here to here, stop here. That means if you move further, it may not be true. So if you now move further and it's still true, you're done. Do you understand? That's the meaning. Now, but this example is significant. Now, let's check 4. 4 factorial is what? 24, right? 4 square is what? It's 24 less than 16. You see? It fails this one. It's only true for the first 3. Do you understand my point? If we check when n is 1, it's actually less. When n is 2, it's actually is correct, right? When n is 3, it's correct, but when n is 4, it fails. And indeed, when n is 5 and on, it will actually fail, because that's why I asked you earlier, this one, which one is big? You just choose at random. In maths, don't do that. Do you understand? You can check by induction. Let's get started. So now I will give some example on induction. I want to tell you that it will actually be a guide for me, you know, so that I will not be doing 3 before 2. Do you understand? And I will not be too far from your curriculum. Do you understand my concept? Now, example or what example? Now, before I move to the example, do you have any question with these inductive steps? If you have question, ask question. Do you understand me? So, except you understand totally. Proof by induction. Prove the following by mathematical induction. Number 1, let us use what you have there. Summation of k starting from 1 to n of k, you are told is equal to n plus 1 divided 2, right? The second example, summation k starting from 1 to n, let's say k squared, is equal to what? n plus 1 to n plus 1 divide 6. Okay, I'm going to write the third one, but I won't do that. You will be the one to solve that. I'm sure by the time you see all these examples, these first 2 examples, the third one will actually be so trivial. Let me try to write it here. 3. Of course, you know it, isn't it? If you are conversant with your textbook, I'm sure you would have seen it before. Or are you just seeing what I'm writing for the first time? I don't know why I don't really believe that. But actually, at the same time, I don't see the reason why you should be telling line to me for the first time. Can we continue? Good. The first one, solution. Number 1. Now, summation k starting from 1 to n of k is equal to n plus 1 divided 2, right? What does this mean? And how does it relate to induction? Very good. Now, this summation k starting from 1 to n, you see the way I'm reading it? This summation k start from 1 to where? N of what is in front here of k. Do you see that? Now, this k is what you will take note of. Summation means addition. Summation means what? Addition. What are you adding? What is in front? K. What is k? 1, 2, 3, 4. Do you get to where? N. Do you understand? N can be any number. N can be 10, N can be 20, N can be 30. Do you understand? So this means 1. This is the scale I have in front here. Do you understand? Summation, addition. Why do I start from 1? K start from 1. The next number after 1, 2. The next one, 3. The next one, and it goes on like that. Whatever k n is, stop there. Do you understand? If n is 10, it means 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus. Thank you very much. If k starts from 2, then it will start from 2 plus 3 plus 4 plus 5. Do you understand? In fact, let's look at something. Summation of k starting from 5 to 8 of k raised to power 3 over 4. You see? This is what you will be adding actually. You must take note of what is here, k. It starts from where? Look at it. Look at what I'm going to write. This is k, 5. Do you see it? Raised to power 3 over 4. That's what I will write. The next number after 5, 6 raised to power 3 over 4. Next number, 7 over 4. Then 8 raised to power 3 over 4. Next number, thank you very much, because it stopped at 8. You see now that you know it. What if you are not giving? You have to be given. You have to be given, at least for your level, you have to be given. Do you understand? So, this is what this means. 1 plus 2 plus 3 plus 4 till you get to n. So, how does this effort? It's actually good. In fact, this question, like, let's come out of math induction. Let's do what? Suppose we come out from math induction, there are many ways to prove this thing. The first thing you can see is, if you can see, this is actually an arithmetic series, isn't it? First term is 1, common difference is 1. If you use that formula to find the nth term, you get this. There's actually some other ways to also prove this, like to solve this question as well, but don't let us move out so soon. Now, let's do this. We want to prove by induction. Do you understand? Let me tell you, okay, how does this help? If we are told to calculate 1 plus 2 plus 3 plus 4, what is the answer? 10. Oh. Now, everybody, 1 plus 2 plus 3 plus 4, what is the answer? 10. So that's like saying summation of k starting from 1 to 4 of k. Just put 4 here. 4 plus 1. 4 plus 1 is what? 4 times 5? 20 divided by 2. You see that? Wow. You will say you prefer numbering by yourself. Now, 1 plus 2 plus 3 plus 4 till 100. Tell me. 5050 actually, because I use this. If you do 1 plus 2 plus 3, when you get home, after this class, go and try it. 1 plus 2 plus 3 plus 4 till you get to 100. Confirm whether get the same answer. How are you going to? Just put 100, because take the last number you're stopping at. Put 100. 100 times 101 divided 2 50. 50 times 101 is 5050. So do you understand? But then when n is 1, we now prove now. We prove by induction. When n is 1, you see that? I'm already doing the first case. When n is 1 means summation of k starting from 1 to 1. It means start at 1, end at 1. So what do you have at the left hand side? You only have this one. Left hand side is 1. Do you understand?
No.
This is left hand side of the equation. This is what? Right hand side of the equation. So when n is 1, it means summation of k starting from 1 to 1. Start at 1, end at 1. It means only this. When n is 2, this is it. When n is 3, this is it. When n is 4, do you understand? When n is 5, like that. So when n is 1, it's just 1. Left hand side, 1. Do you understand? What happened to the right hand side? You know, right hand side is n plus 1 divided 2, right? But what is the value of n? 1. Put 1 multiplied by 2, isn't it? The answer is will give you 1. Do you understand? So, therefore, it is true for n equal 1. You see, I'm done. Basically, in advanced level, I don't need to shoot for n equal 2. It's okay. Once I show for it is true for n equal 1, I'm done. Like, I'm done with this A. But I will show you 2, because you are just like learning. Some of you might know it before, but it's okay to show 2 for now. You understand? So when n is 2, don't interpret. What did I say? Don't interpret when n is 2 for this. If I like, show when n is 1, when n is 2, when n is 3, when n is 4 and 5, we are still doing A. Do you understand? If we have not assumed, then assume it is true for you are still doing anything you are doing is still A. Do you understand? So now, when n is equal to 2, what happened? What happened to the left hand side of the equation? 1 plus what? 3. Right hand side. Somebody is thinking I'm wrong. But let's see. Right? And I'm telling that person we shall see. When n is 2, put 2, what do you have? Scholar. 2 divided 2, right? 3. You do that from your brain, right? That's very smart. Isn't it? N is equal to 3. What happened again? Is it now false? It is true for n equal to. Somebody went for it. You're welcome. What did you see? Visions of God or visions of math? It is also true for n equal to. I am done with the basic base step or base case. Do you understand? The next thing now, assume. That's how you write it. Assume it is true. Assume it is what? For n equal to k. What does that mean? I'm going to explain further. That is, assume it is true for n equal k. That is, it is true for 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 till you get to k. Do you get that? Now, it's equal to, what would this one now be? This is what you have. Do you get that? Do you understand? Assume it is true for n equal k. 1 plus 2 plus 3 till you get to k is equal to. Do you understand what when I was explaining this earlier? You know, you check for 1, you check for 2. I told you you can't continue to check for 3, 4, 5, 6, 7. You just assume that, oh, let's assume it is true for the first 10. This is the first 10. 1 plus 2 till the 10. Do you understand? Or let us suppose it is true for the first 100. 1 plus 2 plus 3 plus, you get to 100. And don't forget, since I'm stopping at k and not n, this will become k plus 1 divided 2. Do you understand? Now, lastly, you see, this number 2, or this second case, is the simplest part. The only way you can get this wrong is if you are interpreting it wrongly. Do you understand? But if you are not interpreting wrongly, then it's good. Do you understand? So see, now we prove for n equal k plus 1. Do you understand? I'm done with B. Just as I'm assuming it is true for n equal k. This is it. What do I do? When n equal k plus 1, what happens? That means I'm adding to k plus 1. Isn't it? Do you understand? When n equal 2, I am adding till 2, right? When n equal 3, that means I will add till 3. When n equal 4, I will add till 4. When n equal k, I will add till what? When n equal k plus 1, I will do what? 1 plus 2 plus 3 plus 4, and it goes on like that. Plus k, right? Plus what? Oh. Plus k plus 1. Do you see that? You don't understand? Okay. Look at it this way. Assume k is 10. Wait. Assume k is 10. That means I'm adding from 1 to 10, Abi. What will be k plus 1? That means I'm adding to 11. That means I'll add 1, 2 till 10, then 11. So this is 1, 2 till 10 plus. Do you understand? So now, this will be equal to, I'm going to use, okay, when I'm done, I'll do that. I'm going to use this assumption. This assumption is not a figurehead. What is, from this assumption, what is 1 plus 2 plus 3 plus k? 1 plus 2 plus 3 plus k is equal to this. I have k plus 1 divided 2. That is the meaning. Thank you. You can see what I'm saying already. Plus k plus 1. I know so many people probably it's not seeing it yet. And I know why probably you can't see it well. It's because of the way I'm writing it. Now, look at it. I have 1 plus 2, look at it, plus 3. Till you get to k, right? Plus k plus 1. Do you see that? From the assumption, what is 1 plus 2 plus 3 plus till you get to k? This is it. So, look at it. 1 plus 2 plus 3 plus k. Do you see that? Plus this new person. This new. Do you understand?
Yes.
Good. So, what am I left with? This will be equal to, now, if we look at this very well, k plus 1 is common. Actually, see, what is left here is just to simplify. Do you understand? There is no particular way, you must do this. No. You can open this bracket, k squared plus k, understand? Divide 2, then you find the LCM and do some other things. You factorize eventually. And I can just factorize immediately. K plus 1 is here, obviously, right? K plus 1 is here, k plus 1 is here. Factorize. K plus 1, right? Open, let me even open a big bracket. You have k over 2, isn't it? Do you understand? Do you understand? If you find the LCM here, hello? Okay. Yes? Why did we add k plus 1 to it? Why did we add, I have explained that already. Let's assume n is 10. It means 1 plus 2 plus 3 plus 4 till you get to 10. when n is 11, k plus 1, 10 plus 1, 11, you still pass through 10. Do you understand? So, it's okay. Now, find the LCM here. What's the LCM here? 2. I just want to write here immediately. The LCM is 2. You will notice what you are going to have. But, hello?
I.
I'm there. So, I have k plus 1. Do you understand? LCM is 2, right? 2 divided by 2, 1. 1 times k is k plus. That one is what? 1 over 1, right? 2 divided by 1, 2. 2 times 1 is what? At the end of the day, I can actually write 1 over 2, k plus 1, k plus 2, isn't it? If you don't get that, it's easy to write, okay, I have k plus 1 here, k plus 2, and at the denominator I have 2. Whichever one you are writing is fine. Do you understand? We are done. We are through. Now, how do you know what you have done is correct? You know, it's 2 questions. It's either what you have done is correct, or you have done rubbish with what? Hello? Are you here? It's either what you have done is correct, or you have done what? Rubbish with confidence. Now, how do you know that this is correct? Come to this place. You see, that's the question, right? Replace n with k plus 1. If you get this, you are correct. If you don't get this, rubbish with it. So put n, this n, k plus 1, right? This another n, k plus 1 plus what? Divide 2. If you do this, 1 plus 1 will give me what? So I am done. So therefore, you have the question right.
Yeah.
Therefore, by mathematical induction, thus, or therefore, or hence, by math induction, or by induction, what do we have? Summation of k starting from 1 to n of k is equal to n plus 1 divided 2. That's all. It's a long proof, isn't it? Or at times they might actually give you summation of k starting from 1 to 10 of 2k plus 3. You might be told to evaluate this. This is easy because it's finite like this. You can do the 1 to 10. Do you understand? And actually, on your calculator, you can also do that as well.
So basically, if you want to use calculator to solve this type of question, you have to have this type of calculator called natural display. So the first thing you are going to see is if you go to your on button and you look down to that log, the one with that other color, you will see there is a summation symbol. How do I press that? I will go to shift, I'll press shift, then I'll press this. You see it's showing me summation, and if you look at what's on the calculator, you will see s starting from something. You have to input that yourself, then you put something in front, then on top as well. So what this is saying is that I'm going to input this, but anyway I see k, I put s because the calculator is programmed in such a way that the variable is x. So s starting from 1, I'll come here and say s starting from 1. I'll use the arrow key. As you can see, s starting from 1, then up. I press the up arrow key, I mean this place, to 10 because that's the question given. Then I have 2k plus 3, isn't it? Here I will have to write 2s plus 3. So I'll write, look at what I'm doing, 2 s, this is x here, so I'll press alpha s, alpha here, then press this x, that's x plus 3. So once I am done writing this, I will just press is equal to, and the answer will come out. The answer to that question is 140. So this will be equal to 140.
Now look at the second one. Of course. Hello. Let me show you this again. This one means hello. I won't waste time now. This one means 1 square plus 2 square plus 3 square. So you get to what? N square. Thank you very much. So this one will be equal to n plus 1, 2n plus 1 over 6, and we want to prove by induction. So again, you can be asked what is 1 square plus 2 square plus 3 square. You get 100 square. If you know this, then the better. You just put 100 here. You tell the answer immediately. Do you understand? So now, what happened is that we'll prove for n equal 1, right? Proof for n equal 1, proof for n equal 2, and not like that. So when n is 1, what happened? What happened to the left hand side? Thank you very much. That's very correct. You see now, you are telling me after one example. What happened to the right hand side? N, you know, n plus 1, right? 2n plus 1 divide what? 6. You will put 1 here. What do you have? 1, 2, 6. Is it? Sorry, 3. Do you understand what I'm doing? Good. Then this will be equal to what? 1. Thank you very much. And that's the answer. Do you understand?
Yes.
So now, should I do for n equal 2?
Yes.
I know you. Okay, you have arrived. No need. No, you have arrived now. No need. Some people are still like, they are not still sure. Let him do it though. Okay, hello. Try it while I also do it on the board. When n is equal to 2. The left hand side, if you know you can't try it, then follow me on the board. If you can try it, then you have to also look at what I'm doing. 1 square plus 2 square, that's 1 plus 4, and that will give 5. What happened to the right hand side of the equation? Oh, I'm supposed to write something here. I'm supposed to say therefore it is true for n equal 1. Do you understand? Hello? I'm supposed to write therefore it is true for n equal 1, like we did in the first example. So right hand side will be what? You know, this is n plus 1, 2n plus 1, divide what? 6. What do I have? 2. Don't forget n is now what? 2. 2 times, you have 3, isn't it? 2 times 2 is what? 4. Plus 1. Divide
6.
2 times 3. This cancel 6. You have 5. Or you have 30 divide 6. The answer is what? Thank you very much. So I won't forget now. It is true for n equal what? Now what is the next thing to do? Tell me. Assume. Thank you very much. We have this now. Assume. It is what? It is true for n equal what? Tell me what I'm supposed to write. N 1 square plus 2 square plus 3 square. You get to assume it is true for n equal k because it's correct. Let's continue. What are we left with? Now, we prove for what? N equal k plus 1. So what does that mean? I will add k plus 1, isn't it? Don't forget, I will pass through k. It's no longer new, isn't it?
Yes.
I have 1 square plus 2 square plus 3 square plus what now? K plus 1 all square. What will this be equal to? You have to remember the assumption. What do you have? Plus. Thank you very much. The last thing to do, or what you are learning, is basically to simplify, isn't it?
Yeah.
You can decide to open the bracket, find the LCM, or factorize anyone you want to do. Do you understand? Open your teeth. Hey, yeah. Don't worry, I will show you. I will show you. It's okay. So, do you understand? Now, what is common? Because I like factorize, I don't like to expand. K plus 1 is what? Good. When k plus 1 is out, what do you have? K, 2k plus 1 divide what? Plus what? Plus what? Okay. Well, it's okay if you don't understand, just look at it. K plus 1 is here, k plus 1 is here. That is why we are able to factorize k plus 1. So the k plus 1 here is out. We are left with k, 2k plus 1. Do you understand? Divide 6. This k plus 1 whole square means there are 2 of it. Do you understand? So 1 is out, it remains just 1 of it. Do you understand? Now, LCM now, this is over 1. This will be equal to k plus 1, right? LCM is 6. 6 divided by 6 is what? I have this at the numerator, right? But let me just expand immediately. I have 2k squared plus k. Where? N plus 1, 2. Yes. Thank you very much. We are supposed to put k plus 1 here when we are done to confirm whether we've done rubbish with confidence or we've done the right thing. Do you understand? Look at it. We want to prove that this is equal to this. We have done the basic step, right? When n is 1, when n is 2. We have assumed it is true for n equal k. Do you understand? If you're using this throughout, we want to prove this one. Do you understand? Let's check whether this person is good. You have not checked, you are already using that person. So, you understand what I'm saying? You want to join football team. Do you understand me? You have to go through the training. When you are okay, oh, this person is good now, they take you to the field like you play in reality. But if you are not equal to the task at the training field, probably you will just be for substitute in case there is emergency and the right person is not on ground. Do you understand? This is what we want to prove. Do you understand? If you remember the first thing we did, when we added this, are you with me? We looked for, you understand? We saw, then when we got the answer, then I now said, if you want to know whether what we've done is correct, you will come back to that and then put k plus 1 and see whether it's what you have there as well. Do you understand me? So that's what you do. So now 6 divided 1, 6, right? 6 times k plus 1. 6k, yeah, that's 6k plus 6 open bracket k plus 1 or 6k plus k. Anyone you're saying is correct, right? This will give me k plus 1. Then what do I have at the numerator now? Plus 7k plus 6 divide what? Do you understand? Now, look at this. I will actually try to factorize this 2k squared plus 7k plus 6. I have 2k squared. This is just a rough work, right? Then you bring this, in case you don't know how to, 2k squared multiplied by 6. Do you understand? what do you multiply together that will give you 12? When you add it, you have plus 7. 3 and 4. 3 times 4 will give me what? 12. 3 plus 4 will give me what? 7. So if you put k, this one will give me k squared, right? That's the normal way of like solving. Do you get that? Now, to round off, hello, I have 2k squared plus, instead of writing 7k now, I'll write this plus 3k, right? Plus 4k plus 6. Can you see that? What is common here? Only k, right? What do you have? 2k plus 3. What is common here? What do you have? The one in the bracket is now the same. The one outside, k plus 2. Do you understand? That's how to factorize. Will now be k plus 1. Are you there? Will be equal to, then inside there I have, what do I have? K plus 2, 2k plus what? Divide what? Do you understand? Hello? So then lastly we have k plus 1. I told you you can join them, isn't it? K plus 2, 2k plus 3 divide. And we are done. We are through actually. We have simplified this. Do you get that? Now, but it remains one thing. How do you know you're correct? Hello? How do you know you are correct? I told you earlier, you come to this. I have rubbed up the question, but you come here, isn't it? Hello? You will come here, isn't it? Put n to be what? K plus 1. Let's come there. This is n. You have what? What do you have? Isn't it? Then you have 2. Do you understand? Eventually this will become k plus 1, isn't it? This one will become what? 2k plus 2, Abi. 2 plus 1. 2k plus what? Is that what we have? We are done. Where's my duster? Then we are done. We have, eventually, we have, therefore, it is true, right? For n equal k plus what? Do you understand? I'm done. Or else by induction. Summation of what? K starting from 1 to n of k squared is equal to what? N plus 1 to n plus 1 divide what? 6. Do you get that? And that's all concerning that. So, you can solve manually. What is manual? K starting from 1 to what? 9. You will do, hello, look at it. You will do 1 raised to power 3. 1 plus 1. Do you understand? That K, when K is 2, 2 raised to power 3 plus 1. When K is 3, 3 raised to power 3 plus 1. 4 raised to power 3 plus 1. Do you get that? 5 raised to power 3 plus 1. So you get to 9 raised to power 3 plus 1. Do you understand? You will now add. That is normal, like you understand. But if you want to use that formula, assuming I'm the one to do this now, and I have k raised to power 3 plus 1, look at what will happen. Hello? I will have summation k starting from 1 to 9 of k raised to power 3. Do you understand? I will separate it because I can actually separate. But summation of k starting from 1 to 9 of 1. Do you see that? What is k starting from 1 to n of k raised to power 3? I have given you. See, those three things I gave is important. For k, n plus 1 divide 2. For k square, n plus 1, 2n plus 1 divide 6. Plus k cube is what? isn't it? That's what I will use for this one. I will just pretend to be 9. Do you understand? Some people don't understand. So this one would have been.
Sorry, one more question. So that means the highest will be k raised to power 3. Because you give us. Sir?
That means what?
The highest will be k raised to power 3. Because you give us k1, k raised to power 1, k raised to power 2, k raised to power 3. Essentially, given as a fact.
That means.
Like k raised to power 3 now.
The highest power.
Where the highest power will be 3. You know, questions. That's what I'm saying.
Oh, okay, yes. I think for your level, yes. No, 2025 is the answer. I'm scholar. Now, wait till. Do you understand what this one is? See, whenever this is a constant and it's starting from 1, the answer is just this. What is here? Let me. Okay. You know, I've given you this. Now, when you have k starting from 1 to n of 1, and 1 is in front, the answer is just n. So this one will just be 9. So you solve this 9 squared, 10 squared. Oh, the answer is no longer 2025. 2034. Are you sure? Oh, scholar. You've gotten this since Abi. Why we were wasting time here?
Anytime you have a finite summation, that is k starting from 1 to a number that is 9, 10, 11, 30, 100, once you are sure that it is not a letter, that is, it's not k starting from 1 to n, you can always use this calculator to solve it. So I'll quickly show you how to use this second example as well. Shift, as we've done earlier. You see, summation is showing I have k cube. I'll immediately write this one. That's s. Don't forget, s is what calculator understand. S raised to power 3. You can see raised to power 3 here, or I can use this to just input the raised to power 3. S raised to power 3. Then I have to come out of that power. You see, plus 1, plus 1. So I'll use the arrow key, k starting from 1, isn't it? So that's from 1 to 9. Arrow key up to 9. So the next thing that I need to do is just to press the equal to. The answer is 2034. So the answer to this question as well is equal to 2034. And that's all. And that's how to use calculator to solve summation question. Thank you very much.
Second marathon class, events 114. We did events 115 last week with Green Abayomi Adedeji, the ex-president of Physics Department, BGS of Physics Department, University of Lagos. So today we brought down Jeremiah Adedeji in Presidomath, the current best mathematician in Nigeria by NFC National Mathematics Competition. Thanks so much for your time. Really appreciate it. Thanks so much. Immaculate who came through during the class, one of the best mathematicians in Nigeria. See you guys later. Bye. Thanks so much everyone. See you guys. The day is here. Who is here?